Hey guys, in this video I'm going to show another nested parametric family with an array. In a previous video I showed the array sort of in a radial around a table and more of a kind of a component and a furniture standpoint. This is going to be a linear based array. We're going to do something maybe a little bit more I guess usable or realistic. We're going to create like a standing or stacked bond CMU wall family that's adjustable with actual modeled CMUs. So it's going to be a kind of a cool family, but it's going to involve the same principles, but just more levels of nesting, a little bit more complicated formulas. Well, slightly more complicated formulas, nothing too bad. So to get started, I've cut out a lot of work by going ahead and creating a CMU family here. This is just a single CMU block. It's got some concrete fill in it that's associated with, if we go ahead and pull up the parameters here, got grout material, block material, concrete filled, yes or no with check. Like, these are all the parameters that are built into it. So this takes out a lot of legwork. So this is going to be kind of the basis for the rest of our families that we're going to be building on. So from here, we're going to create a, so if you get what I'm saying, we're going to create a family that's line based. So as you draw the line, we're going to extend it out linear array. So the blocks are going to kind of, shoot on out that way. And then something's going to control the height. So that'll control an array vertically. So the first thing to do is create a family that has a vertical array of these blocks on it. So this is kind of our starting point. This is our block. And we're going to go ahead and create a new family. And it'll be a just generic model. All right, cool. So if I hit window tile, when you create a new family, it creates all these views for you. It's family 8, I guess, is what we're kind of looking at here. Whereas the 8-inch CMU block family is right there. Oh, one thing about this block family that I kind of wanted to show you before we get too started. 8-inch CME block. We'll go to the reference level. I have created, symbolic lines in here to where it looks nice in 2D. Also, if we click on the front here, yeah, so you see I got some symbolic lines and some hatches and stuff. So this, if you cut a section through this block, it's gonna look like a detailed out block. So it's a pretty dynamic family. I'm not going to go into too much detail about how you can turn on and off, these symbolic lines and hatching and stuff. We're just going to leave it on for these purposes. I really just want to focus on the arrays and just to give you a different taste of how to use it. Anyway, I wanted to show you that because it's kind of a cool little family, just to give you an idea of how you can use some of those symbolic lines. All right, so we got our block here. We want to load it into this family, so we use this load into project button. And there we go. We have our block. We're going to go ahead and align it with those reference points. We want it to be completely centered in this family, because again, just like the table family that we did, if it's not centered, it will goof you up later on down the road. So we're just going to make sure it's centered in this one. If we're done with this family, we can go ahead and close it out. I think for what we're doing, I'm done with it. So I'm going to go ahead and close it out. All right, cool. So we have this reference plane. I also want to open up the front view. And we'll possibly open up the 3D view. We're going to window tile all these guys. Actually, let's just look at the elevation in the 3D. All right, so let's create an array, a vertical array that will send this thing up. Select on the object, go to array, and we set a base point. Honestly, it's trying to pull an endpoint from the bottom of that family. That's okay. We can start from there, or we could start from the intersection of the two reference planes. It's probably okay to start from this endpoint. If you did want to specifically select a point, and like when I'm mousing over, it's not giving me that, I can kind of tab through. But if I know see, it's not giving me that intersection. That's okay. I can right click, go to snap overrides, and go to intersections, and it's going to find the intersections that way. So I don't know if I'd ever kind of told that to you guys about how you can do that snap overrides just by right clicking. You know, if we were doing it again, right clicking, and then you can click the override, like the one you want to focus on, like endpoints or whatever. All right, but from this endpoint, that's an okay starting spot. Again, if we look up here along the top, we need to make sure that this is right. This is going to be different than the way that we did it last time. Obviously, we don't want to do radial when we want to do linear. Group and associate obviously needs to be checked because we want it to stay in a group. And instead of going to last, we're going to go to second because we want to create a spacing. We want this thing to somewhat be infinite. If we just keep typing numbers, it's just going to keep extending up. Remember, we're doing we're doing how the wall moves vertically, or giving it its height. So let's go from the endpoint and essentially go up to the very top. It's 8 inches, which makes sense. It's an 8-inch CMU. And then this can be 2, 3. I'll just leave it as 2, whatever. All right, so let's now what we want to do is we want to control this array through a parameter. So let's open up our family types. I'll just keep it in the middle right here so we can, as we start playing with it, we can see this thing jump up. All right, so let's add a parameter. This is going to be a instance parameter. It doesn't need to be a type parameter. Instance parameters, again, type parameters you can't really control in a nested environment, only instance parameters. So if we know this family is going to be nested in another family, any parameters that we want to create that we want to be able to be controlled in the other family, they need to be an instance parameter. So this is going to be height. I know that I want to create a parameter on the other one where I can actually type in like 5 feet high, and it figures out the amount of blocks for me. So I don't want to really call this one height. Vert block, like vertical block. That works for me. So okay, vertical block. Oops, we made an error here. This doesn't need to be. This needs to be an integer. Not a length. Once you kind of set that, you can't redo it. So I'm just going to delete that and do it again. Sorry about that. Vert block instance, and not length. It needs to be an integer because it's controlling the amount of blocks that are going up there in the array. So we click OK. There we go. V block or vert block and default, and then the value is the integer. Okay, so now we just need to select the array. I'm just gonna kind of mouse over where that line keeps showing up. I'm gonna select that line, go up to label, and there's the vert block. Click it, and there we go. Now it's assigned. So if we come back in here and we bump it up to like 7, they jump up. We're going to plug that down to 2. One thing to keep in mind when doing arrays is that you can't go less than 2. If I go down to 1, this thing's going to give me a big old fat error saying parameter vert block has an invalid value. So essentially, if you bring it down to 1, it's no longer an array. It's just that it invalidates the array. You have to have at least 2 for it to be an array. So we'll just leave this on 2 for now. and then click OK. All right, so we have a family that controls the vertical, the amount of blocks that are going to be in that vertical array. So we want to nest this in a line-based family. So essentially, we want to take this family and put it in another family that will create an array from this family along the vertical line. That's not the best way of explaining it. I'm sure that went over everybody's head, but it'll make sense once we start doing it. All right, so I'm gonna just leave the 3D view open. I'm gonna create another family. New family, and this is going to be a generic model line based, and we hit open and WT window tile. All right, cool. So here's our linear based family 9, and family 8 is our just generic block with a vertical array. So we're going to go ahead and load this in. And we're going to just place it. I'll align it later. So if, like, for instance, I didn't have this open and I couldn't do this load into project, just like the way that we did it with the tables and chairs, not a big deal. You just go to create and component, and you can place the component. You notice if I click on place components or whatever, over here in properties, you'll see the family 8. That's the family that we just put in there. So it's just an easier way of doing it. If I've been editing this thing and then I just have it open, I just hit load in project, and it just makes it a little bit easier on me. I'm going to leave this family 8 open because there may be something I need to edit on this side. Probably not, but just in case, I'm going to leave it open. I'm just going to kind of maximize that there. All right, so let's go ahead and line this block up. So if you see the way that the linear-based families work, or the line-based families, here's a reference line, the reference plane that defines the length of that reference line. So you see that it may be a little difficult to see, but it's just a green solid line, not a dashed line like a reference plane. It's a reference line. But as we push and pull this reference plane, you'll see that this dimension, which is obviously attached to a parameter, says length equals. We know that that's a parameter. It is moving as we do this thing. So let's take a look at the parameters under the family types. Yeah, there's our length. So it's got parentheses default, which is basically telling me that that's a instance parameter. Which makes sense because the way that line-based parameters work, if we were to load this, for instance, like this works just like a wall. So if we were to, load this into a project, you would click, a start point and end point, and it create like a, a line, like anything line-based. So we're going to have this block kind of react with this line. So if we click on this reference plane, this is the center, front and back. This is, if we select on this reference plane, this is left, and this is right. So essentially, it's the start point. You get the sense that this is kind of the center or the starting point, and this is the one that moves. So we want to go ahead and place this at a start point. So I'm going to use the align tool, which is right here, align, or AL. Align the center reference plane to the center of my block. And if you saw how, let me do that again. If you saw how when I mouse over, it's giving me kind of these snap lines right there, right? We didn't create that. That is actually the location of the reference plane in the previous model. So that's why it's so important to get this thing centered on those reference planes. If it wasn't centered, it may be up here or something like that, and it just really wouldn't work well. So anyway, we're going to align that center to this center, and then this left to the beginning of my family here. All right, cool. Yeah, we'll go ahead and lock it too. So now it's constrained there. All right, awesome. So let's look at this thing in 3D. That's my previous family. I'm just going to minimize it. All right, so there's my reference line, and there's my family, family 8, loaded in. So what I want to do is, obviously this instance length of this line base, that's what you draw, so it's like 4'3". I want to create an array and a formula that adds in the amount of blocks based on the the length drawn. So I'm going to create another array here. I'm going to select this block and go to array. So again, this one's going to work the same way. We want it to be linear. We want it to move to the second. We want to create a nice the correct amount of spacing on this. So this is an 8-inch block. It's a typical block, meaning that it's 1'3" and 5/8 in length, I think, and then you would have a 3/8 thick grout bed in between the blocks. So the actual kind of spacing is around 1'4". So we're gonna do that. We're gonna create our spacing at 1'4". And let's just put 3 in there for the heck of it. All right, I kind of want to just check my spacing real quick, make sure it's right. Yeah, 1'4". That would be from the end of one block to the end of the next block will be 1'4", meaning the grout, the grout bed would be 3/8 of an inch in between. That's typical block. And if we look at it in 3D, yeah, look, that's a stacked block wall. It's kind of what we're looking at there. All right, so now we have this array, and there's 3 of them in there. Let's go ahead and create the parameter, or just create a parameter that's associated with that number of blocks there. So yeah, this is going to be an instance because it has to be connected to another instance. I'll talk about that here in a minute. And we had a vert block, so this is going to be a hors block, whatever you want to call it. And click OK. So we have our horizontal block there. All right, let's open up the family types here. So here we go. We have the length, and then we need to get these to react to each other with a formula. The importance that they're both instance parameters, right? So you can't really have the instance parameter of the length associate with a type parameter. Does that make sense? I mean, you draw a length on a wall, and that can't tell all the other types to do something because they may all be different lengths. So, if it's an instance, it relates to an instance. Certain types can define instance parameters, but not really the other way around. Type parameters are the more solid parameters. So anyway, we need to create a formula so that the length informs how many, like the integer here on this array. We're going to use, so let's see, length, how would we do this? So equals, yeah, so it's 4'3", so the number would be, the spacing is 1'4", right? So, 1'4" times 3 would give you that length. So we just kind of want it to work in reverse. So we're going to type equals length divided by 1'4". Okay, so we'll click OK. And as we pull this thing, we'll notice Our parameter seems to be working. Let me pull this thing down. So cool, yeah. When you know, we can test it here too. You know, just type in 6 feet, and you notice the number will change on us. So the only issue that I'm seeing here is that as I draw this thing, as soon as it gets to about halfway through this block, it's adding in a whole nother block, right? And the reason is because Revit's pretty smart. It's doing the math, and you know, as soon as right, this can only be an integer, so this can't be like a 4.5. This can only be a 4 or a 5 or a 6. It can't be like a decimal point. But obviously, this formula right here, you know, with feet and inches divided by another, you know, like 1'4", that's going to give you, you know, something with a decimal point. As soon as this hits, as soon as the answer hits 3.5, it's going to go ahead and round up to 4. So, you know, we'll see it on the next one. As soon as it hits about 4.5, it's going to pop in a whole nother 5. So, you know, that could be, you know, good. That could be bad. It depends on how you want it to act. To me, I don't like that. I want it to go to where as soon as it's at the length for a whole nother block, that's when it puts in the block, not halfway through. So that I know that it's, you know, that the actual length of the geometry is not longer than the length that my wall is supposed to be. That just seems like the better way of doing it to me. So I'm going to put a qualifier on here. Something that we haven't really looked at yet is rounding. You know, rounding down and rounding up. You can tell Revit to round up or down. If we kind of flip back to our notepad here with some of our formulas that we've done up to this point, I guess the formula statement that you want to try to use is round down and round up. These are kind of the new ones that we're using. They work the same way as your and or your ors, or, you know, whatever, where you do round down, parentheses, then you would type in your statement, and then that would be it. So if our statement was length divided by 1'4", right, that's where we would insert that that length divided by 1'4". That would be our statement. So that's what we want to type in. So I'm just going to type in round down, parentheses, and then add a parentheses at the end of that thing. And then we're going to hit apply. Okay, cool. So now when we adjust this thing, it's only when we get to the full length to justify that extra block, because it's when it's going to put in that block. Now this works the same way. If we get under 2, it's going to freak out on us. Yeah, and here's our error. Parameter horse block has an invalid value. Right. So we're going to have to stay above that too, and that's okay. You just got to be aware of, you know, what breaks your models. All right, so we have a line-based formula, or a line-based family here that these will go down. Now what we want to do is we want to add a height, so where you can type in a length and a height, and you got a block wall that kind of reacts to that. So let's go to our family type here. We have our length. Let's add another parameter here that is height. Type parameter length and group it under dimensions. We want this to be an instance. Okay, so length is under constraints. So we'll just modify this and move the category from dimensions to under constraints. I want the length and the height to kind of be next to each other. Okay, so length and height. Let's just put, I don't know, 8 feet of the height. It's just just something to start off with. Okay, hit apply. Okay, and So what we need to do is find the parameter that we defined for this nested family and associate it with a new parameter that's called, another vert block parameter within this family. And then we can have the height and the vert block associate with each other through a formula. So I'm going to go ahead and click on this guy in our array. If we look over here in the properties, right there, vert block, that's the number right there. If we change that to 3, for instance, and we finish, it's going to do all of them because they're in a group. But what we want to do is associate this with a family parameter. There's a horse block. Oh no, we don't want to do that. We want to create another one that's vert block. Add a parameter. This is going to be an instance. And vert block. Now it's perfectly okay for the new parameter that you create to be the name the same as the older one. That's not going to mess anything up. So hit OK and hit OK, and we're going to finish this thing out. Alright, cool. Now this is associated, this vertical movement is associated with the parameter in the new file, and now we just need to connect the two with our formula. So we're essentially going to use the same formula here, but it's instead of length, it's going to be height, and it's not going to be 1'4" anymore because it's an 8-inch block, so it's going to be 8 inches. So I just copied and pasted that. Sorry if I didn't talk through that. So round down, this is going to be height instead of length, and then it's going to be 8 inches. Right, does that make sense? Because it's an 8-inch block. And then we hit apply. Oh gosh, okay. You probably saw it jump up here on the corner of the screen. So we'll just test this a little bit. So we'll make it a 4-foot high wall. Hit apply. 6 foot high. Apply. Cool. Alright, so really the best way to test this thing is, this is essentially what we wanted to create is our line-based wall. We can type in a length and a height, and it's going to adapt with the amount of blocks. Let's go ahead and let's put this family, load this into like a sample project, and we'll just kind of play with it a little bit and test it out. Revit, new project, architectural template. And we'll click on this family, load it into project, and here we go. Placement plane on level 1. We see our length here and our height, and this is going to act just like a wall, right? Now, because it's generating so much geometry, it may slow your computer down just a little bit if you're trying to follow along. But you see, as I kind of move my cursor, it's generating that geometry. I'll click it in place. Let's check it out in 3D. Very cool. We can click on that wall, change the height to 8 feet. And there we go. Cool. Now, like our previous family with the chairs, I could go back into the nested family of the actual individual block, and maybe put on a visibility parameter of that, the visibility of the concrete fill, and then we click on this wall, and maybe have our checkbox here to say whether or not it's concrete filled or not. That would be simple enough, but I'll let you guys kind of figure that out. So yeah, that's it for this family. See you in the next one.